A very interesting question from J Advance previous year. Now, in this question, it's basically a sequence reaction. It involves a sequence of reactions, and we have to identify the given R and S product in this sequence reaction. Now, the given substrate is basically an aldehyde which contain the other groups as well. Like we have methoxy group on para position, and there is an alkyne present in this given complex in this given substrate. So we have this alkyne, right? C, triple bond C, and then we have CH2, and then we have an aldehyde group this way. All right. Now this given substrate is being treated in a first step with Hg+2 in presence of dilute H2SO4. So obviously it will undergo Kucherov reaction. So there is Hg+2 and then dilute H2SO4. So it will undergo hydration and Markovnikov's addition will take place. There is addition of water molecule via Markovnikov rule. This reaction is Kucherov reaction, right? This is called Kucherov reaction, which is nothing but addition of water, which is a kind of hydration reaction where water is being added to the substrate, to the alkynes, and getting converted into enol basically, which can get tautomerized to form the most stable keto or aldehydic form. Now this OMe will be in this way. It's not going to get affected, and there is addition of water molecule in this terminal alkyne. So the carbon, to this first carbon center, the OH group will get attached, right? So we have this OH group, and then we have double bond CH, hydrogen will get attached to the second carbon of this alkyne, and then we have CH2 and CHO in this way. Now this enol formed can be tautomerized into a more stable form, so it will undergo tautomerization and will get converted into keto form, right? So there is formation of keto form. So we'll have this way. We have this OMe again, and this will be getting converted into keto form. So we'll have C double bond O and then CH2, and similarly we have this CH2 as such, and then C double bond O and H, aldehyde group. Now, so this is the step first. So in step first, this is Kucherov reaction. Now after that, it is being treated with an ammoniacal solution of silver nitrate, which we already know is Tollern reagent basically. So it is being treated with Tollern reagent. So we have this ammoniacal solution of silver nitrate, right? So this is undergoing a reaction with Tollern reagent. Now with Tollern reagent, this aldehyde group will get oxidized to carboxylate group. So this C double bond OH, the CHO group will get oxidized to carboxylate group, and will have a product this way. This OMe, it is not getting affected, and this will be C double bond O, CH2, and will have C double bond O and O negative, right? So this will get converted, this will get oxidized to carboxylate ion. Now after that, in step third, this carboxylate ion which is formed is then treated with ZnHg in presence of concentrated HCl, right? So it is then treated with zinc amalgam in presence of HCl, which is a very famous reaction of carbonyl compounds known as Clemmensen reduction, right? So this will undergo Clemmensen reduction. So Clemmensen reduction will take place, and during Clemmensen reduction, it is only the ketonic group, it is only the carbonyl group other than the carboxylic acid group. Remember this carboxylic acid group, this C double bond O of carboxylate is not going to get affected. It is only the ketonic group this way, this is going to get affected, and it will get converted into CH2. Obviously it will get converted into alkane group, right? Hydrocarbon simply. So we'll have OMe, and then to this carbon center, this will get reduced to CH2, and then we'll have again CH2, and this carboxylate ion, since in Clemmensen reduction we are using HCl as well, so this carboxylate ion will get protonated, and it will get converted into carboxylic acid. So this way, so this will be the final product of this Clemmensen reduction. Now after that, this this carboxylic acid which is formed is then treated with SOCl2 in pyridine. So obviously it will undergo substitution reaction with SOCl2, and there is replacement reaction, there is substitution reaction where this OH group is being replaced by Cl, so we'll get acid chloride, right? So we have this way again, OMe, and then CH2, 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 and we'll have C double bond O and Cl, right? So acid chloride will be formed. Now after that, in the next step, it is treated with AlCl3. Now this is very important step. Now this acid chloride which is formed is then treated with AlCl3, and this AlCl3 is a Lewis acid, and this Lewis acid will take up this Cl from the substrate, forming generating a carbocation, and it will undergo, since we have only one substrate, so it will undergo intramolecular electrophilic substitution. So this is very crucial step. So it will undergo intramolecular aromatic electrophilic substitution, right? So the carbocation will be generated. So I'll write down this way. We have this OMe, then CH2, 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 and then we'll have C double bond O and a positive charge on this carbon center, since this Cl in the form of Cl negative will get eliminated or will be removed by this AlCl 3, right? And we'll have this AlCl4 negative, AlCl4 negative, right? Now this carbocation formed is being attacked by the pi electron by the carbon center of this benzene, and it will undergo aromatic electrophilic substitution, which is a type of intramolecular electrophilic substitution. So this carbon center to this carbon center, let's say this bond will get shifted to this carbon center, and this is going to attack on this carbon. So we'll have an intermediate this way, right? Okay, then we have OMe, we have this CH2, or you can form a ring like structure. Now after this intramolecular attack, so there is formation of 1 2 3 4 5 and 6. A 6-membered ring is formed. So we will have this way a 6-member ring, a formation of 6-member ring, right? Now to this carbon center there is C double bond O, obviously. Now since the aromaticity is being lost during this cyclization or during this intramolecular electrophilic substitution, so the hydrogen which is still attached to this carbon center will get eliminated. It will undergo deprotonation, and aromaticity will be regained, which is a very crucial step in aromatic electrophilic substitution, in the mechanism of electrophilic substitution reaction, right? So there is formation of aromaticity is regained. So we'll have OMe, and this way aromaticity is regained and a 6-member ring in this way, right? Now after that, so this is basically R. So we have R this way, this structure we are getting the R structure, which is present in only one option. It is only given in option A. So obviously the option A will be going to the correct answer, but still after this we are treating this R with zinc amalgam in presence of concentrated HCl. So again it will undergo Clemmensen reduction. So with zinc amalgam and concentrated HCl, it will again undergo Clemmensen reduction, and this C double bond O will get reduced to CH2. So the final product of this reaction will be, we have this benzene ring, right, this OMe, and a 6-member cyclohexyl ring in this way. This will be the final product of this reaction, right? So yeah, in option 1 it is given, so option 1 will be the correct option. So it's a very good reaction from your JEE Advanced previous year. Thank you.